Assalamu alaikum. Myself is Sheikh Dewan and my ID 201352998. I am from section 835H. As mentioned in the assignment, we have to do a write a code about AES expansion. As you can see, I have written code in Python, and now I am going to explain it how this works. So first of all, there are three functions I have defined: subwords, root word, and key expansions. So what are the works of them? How they work? The subbyte functionality uses a simplified model of the AES box for demonstration purposes. In practice, it would use a predefined substitution box. The root word and recon. This function discuss the rotation and how the round constant recon is calculated and used in the algorithm. Now the queue expansion. Here I am going to show you how detailed each round key is derived from the previous one and how condition change the operation based on the key size and a round number. So first of all, we imported the numpy. This line imports the numpy, and I have imported as a np, which is a powerful library for numerical operations in Python. Here it's used to handle array efficiently. The subbytes that applies the subbytes transformation, which is a non-linear byte substitution step in AES. The return np dot vectorize. This line applies a simplified version of the subbytes operation. Normally this would involve looking up values in a predefined S box. Here it is simulated by XOR the each byte with the 0x0f using numpy's vectorize to apply the function to each element in the input array word. As the define function, for this the function performs a cyclic permutation on a word. In AES this is used in the key expansion phase. The return that we are returning here is np.roll, which is use the numpy roll function to cyclically permute the elements in the array word 1 position to the left side. Now we are defining the last of our function, which is key expansion. This function expands the initial cipher key into multiple rounds key. Key is the initial key. Nk is the number of 4 words in the k, and nr is the number of rounds, the parameters we have passed in this function. So first word, the nv is equal to 4. This is the block size in words. Block size, this says the block size of AES, which is always 4 words, each word being 4 bytes. Okay. Now in the next line, as you can see, I have called the np numpy. This key array initialize an array w to store the expanded keys. The size is determined by the number of rounds. Here we plus 1 with nr multiplied by the block size nb. Now we are going to perform a loop operations, not one, several. So first of all, the first for loop here is we are copying the initial key into the first nk words of the expanded key array w. For I in range, it starts expanding the key for each word after the initial key. It first copies the previous word into the temp. For second loop, it copies the initial and temp. So here the condition I have given is applies special processing every nk words. Okay. For the next line, where temp is equal to subbytes root word temp, here I am applying the subbyte transformation after rotating the word, then XORing the first byte of temp with a round constant record. The round constant is simulated more simply here than in the full AES, as you can see. For the next else if, um, there the key is longer than 192 bytes. The key which is longer than 192 bytes, it is applying the subbytes step again under specific conditions. And further key processing, here the final key generation, where I am using wi is equal to wi minus nk, other than temp. Here the generating the new round key by XORing the temp with the word nk positions before it in the expanded key and key array. Now we are returning w. This returns the expanded key array. Last, here we are calling the np numpy array. Is initialize an example key as a numpy array of 16 bytes in line number 38. So that calls the key expansion function using the example key with n key is equal to 4, indicating a 128 byte key, and nr is equal to 2 is indicating 10 rounds of AES simply. Now we are printing our expanded key, and let's see what's our final output. As you see, there are 10 rounds happen in this expansion, and in every round this how that is working. Thank you, sir. Assalamu alaikum.